right expression force and 2-point charge Q1, Q2 separated by the diameter R. So meaning you have the force between the two charges. Let's say you have the positive charge and you have the another positive charge, and this is Q1 and this is Q2, and this is a distance between the two charges. So meaning the force between the Q1 and the Q2 is given by the equation constant K time Q1 time charge Q2 divided by the distance square. Number B, so figure show the water molecule consists of one hydrogen atom and two hydrogen atoms. So now the hydrogen is a negative and the oxygen negative, and hydrogen is a positive, right? So the first question is sketch diagram show the all force acts on the atom hydrogen. So the first is the force by the hydrogen atom on the oxygen, right? O. So what happened to the oxygen? Because the oxygen is a negative, so negative atom attract to the positive atom. So the direction of the F hydrogen or FHO, okay, the direction, yeah. So the second force is yes, this is a same process because this is hydrogen. So the force by hydrogen on the oxygen. So what happened to the oxygen? Because oxygen is a negative, so attract to the direction to the positive charge. So this is direction. So if you draw the diagram, so you have a to charge. This is F. Let's say this is a F1, and this is F2. The second force is this is F1 and this is F2. So meaning you have the two charge X on the oxygen atom. So the next is this means the magnitude and direction of the resultant force. So meaning the hydrogen atom, the force X on the hydrogen oxygen atom is let's say this is a F1 and this is a F2. So to calculate the resultant, so to calculate the resultant here, so you must resolve F1 to the, okay, you can use the triangle here, right? So you can resolve to F1 to the F1 to x-axis, and you can resolve F1 to the F1 y-axis. Same process, you can use the triangle here. So this is F2, resolve to the x-axis, so this is F2 x, and resolve to the y-axis, this is a F2 y. So what is the angle here? Angle here, because this is a 180, right? 180, so this is a 108. So meaning the angle here is a 36, and this is a 36. So if you draw the diagram here, let's say we have a, I can use here, right? So this is a 36 degree, and this is 36 degree, right? So this is F1 and this is F2. Or we can use this we have a so we have a F1 and we have a F2, and the angle here is a 36. The angle here is a 36. You can use the triangle here, so this is F2x, and here is a F2y, here is a F1x, here is a F1y. Okay, so the first you must calculate the what is the magnitude of the F1. So F1 here is the force between the two charges here. So the F1 is equal to K Q hydrogen times magnetic charge Q oxygen, and the distance here is 1 exponent minus 10. So this is 1 exponent minus 10 meter. So the value of the F1, and the same process F2, because you have hydrogen and oxygen, so the F2 is equal to K QH QO, this is oxygen atom, and the distance is the same value, 1 exponent minus 10. So if you use the value of the Q QH, QO, QH and QO, and the constant K is 9 exponent 9. So you can use a calculator, and the answer for F1 is equal to 5.94 exponent minus 9 Newton. Right? So the F2, look at the value in the same value, meaning you have the same magnitude here for F, 5.94 exponent minus 9 Newton. Right? So the value of the F1 is equal to 5.94 exponent minus 9, and the F2 is 5.94 exponent minus 9. Right? Okay, so this is, you can resolve to the F1 to the X, F1 to the Y, F2 to the X, and F2 Y. So F1 is equal to 5.94 exponent minus 9. So you resolve to the x-axis, you can use the angle 36. This is cos 36, right? So this is equal to 4.81 exponent minus 9. So F1 resolve to the y-axis, so this is, you can use the 5.94 exponent minus 9, use a sine 36, so this is equal to 3.49 exponent minus 10. So that for the F2, so 5.94 exponent minus 9. So for the F2 here, resolve to the x-axis, you can use the cos 36. So this is equal to 4.81 exponent minus 9. So if you look at the diagram here, Fy, if you resolve to the x-axis direction to the left, so meaning you have a negative here. So F2 resolve to the y here, so we have a F2 is a 5.94 exponent minus 9. This is a sine 36. So this is equal to 3.49 exponent minus 9. So if you find the resultant, this is a resultant for the f, so this is for the fx is equal to, so this is the same value but this is negative, this is equal to 0, and this is a resultant for the for the fy total is a 349. This is a 6.98 exponent minus 9. So the next is to calculate the resultant between two force here. So you must use the equation. So the resultant, this is the force, force resultant at the oxygen atom, or the net force at oxygen atom is equal to square root must use the fy square plus, square fx square. So meaning the f net is equal to, so the value here is fx is equal to 0 plus, and the fy is 6.98 exponent